Hello and welcome back to video 9. This time we're going to be explaining why compression of data is often necessary when transmitting it across a network. This is for topic 3, networks, and this is for the IB Diploma in Computer Science. As you can see, we're still on topic 3, which is part of the core units for the IB. So here we go, we're about halfway down data transmission. We've done network fundamentals, then we're going to be moving on to wireless networking. Okay, so our objectives for this video is to understand the concept of data compression. We're going to explain why data compression is essential in network transmission. We're going to differentiate between lossy and lossless compression, and we're going to identify common file types that utilize compression. Okay, these are meant to be files being compressed. Data compression involves encoding information using fewer bits than the original data, reducing the size of the data that needs to be transmitted over a network. It might not be simply just crushing it like this. We could use something called zip, which does zip files up and make them smaller. So why is it necessary? Sound, images, and especially movie files can be very large. It is therefore necessary to reduce or compress the size of a file for the following reasons: to save storage space on devices such as hard disk drives, solid-state drives, to reduce the time taken to stream a music or video file, to reduce the time taken to upload, download, or transmit a file across a network. Okay, so use cases for compression, as we just said, file transferring. Sending large files, especially over slower connection, is quicker when data is compressed, okay, because it's smaller. Media transfer. Videos, music, and images are often compressed to reduce file sizes, making it easier and faster to stream or to download. And encryption protection. And you may have seen this option if you've ever zipped a file up. Compressed data can also be encrypted. We can password protect it more easily, enhancing security during transmission. Okay, so let's have a little look at lossy compression first of all. This is when some of the original file has been lost. It's used generally in images and multimedia, MP3 and MP4, and it eliminates unnecessary information, lowering the quality that is generally unnoticed by the eye or by the ear. It permanently removes some of the data. It recreates the file using the remaining data and uses algorithms to guess the removed content. Uncompressed data is not the same as the original. I mean, here's a little example for it. Would this work? This is some Python code, and I've compressed it using lossy compression. It might not necessarily work for everything, but here's an example of a lossy compression on a JPEG file. We've grouped the colors together. We've taken out some of the colors. So similar colored pixels are all made the same. Okay, you might be able to pick that up on this. So it finds the groups of repeated data, or in this case, the repeated colors, and records the data only once, along with the number of times it has been repeated. For example, this is the orange or the yellowy color here, the ochre, has been repeated 12 times, and the green has been repeated 6 times. So when uncompressed, an image file does not restore or rebuild to its original form, data size is reduced, but image quality is compromised, as you can see. Also in sound files, you can see the original here in blue, and you can see the red has been compressed. Okay, we've removed this top layer and this bottom layer here. So MP3 uses audio compression to store music in something MP3 format. These are usually 90% smaller than non-compressed music, such as that on a CD-ROM, old technology. They use a lossy compression, removing sound that the human ear cannot clearly distinguish. It might be some sort of dog frequency, or very, very, very low, so you can't pick it up. MP4 can store multimedia also, such as movies, pictures, and sound. Okay, so that's taking away these elements here, the very top and very bottom of a sound wave, sound file. So whereas lossless compression, all the data in the file, and when we looked at that Python code previously, this is the sort of compression we'd be using. So all the data in the file, when uncompressed, is retrieved to its original format. It's used in text files, spreadsheets, databases, and program code, where if there's any information missing or moved, it could be disastrous. The program won't run, of course. So just to recap on the file formats, PDFs, these are fixed layout documents that maintain its original appearance regardless of the software used to view it. We can generally open a PDF in lots and lots and lots of different software packages. JPEGs, either JPG or JPEG, these are lossy compressed files commonly used for web pages. Okay, GIFs, again, lossy compression, usually limited to 256 colors, but these are simple web graphics. But the beauty of the GIF is it can be animated, a series of still pictures that have been put together. The PNG file is lossless compression. It uses an alpha channel to preserve transparent backgrounds. And then we've got MP3 and MP4. This is for lossy music or lossy video formats. Why do we use data compression again? Smaller files, fewer packets, faster transmission, quicker to complete, reduces traffic over the internet, less chance of collision or transmission errors. It improves the download speed of videos, sound, including speech, voice over IP systems, and image files. It speeds up downloads of web pages that use images, and it reduces the space taken up on disks and servers. So in conclusion, data compression is crucial for speeding up data transmission, reducing the load on a network, and saves storage space. Choosing between lossless and lossy compression depends on the type of data that you're wanting to compress and the importance of retaining every little bit of detail of the original file. Okay? As always, 3 questions, ranging in complexity. First of all, we're going to define the term data compression in the context of network transmission. Okay, 2 marks. 2, describe the difference between lossless and lossy compression, providing an example of when each might be used. And for 6 marks, explain why data compression is necessary when transmitting large media files across a network, and discuss how it affects both transmission speed and quality. Okay, as always, pause the video if you don't want to see the answers just yet. So, number 1, data compression is a process of encoding information using fewer bits than the original data, reducing the size of the data that needs to be transmitted across a network. This helps in speeding up data transmission and conserving bandwidth. Question 2. Lossless compression reduces the file size without losing any data, meaning the original file can be perfectly reconstructed. It is used when it's important to retain all original information. Zip files, PNG images are usually examples of lossless compression. Now, lossy compression reduces file size by removing some of the data. That leads to loss in the original quality. The original file cannot be perfectly reconstructed. It is used for media files, where a slight loss in quality is acceptable to significantly reduce the file size, such as MP3 audio or MPG2 video. Okay? And finally, data compression is necessary for transmitting large media files across a network because it reduces the file size, allowing the file to be sent faster and using less bandwidth. This makes the transmission process more effective, especially over slower connections. However, if lossy compression is used, there may be a reduction in quality because some data is permanently removed to decrease the file size. The balance between speed and quality depends on the type of compression that we'll be using. Okay, that is it. That's the end of this video. So thank you very much indeed, and I will see you next time for video 10. Please continue to ask questions, leave your comments, hit notifications, and please subscribe. And finally, if you wish to buy me a coffee, I'd be truly grateful. Please visit buymeacoffee.com/learning zone. Thank you very much indeed. See you next time. Bye for now.